Hello and welcome back to another episode of Math with Son. Today we're going to be doing some exponential real-world problems, solving for time and a little bit of everything in between. But first let's go over what is an exponential function? Well, it is y, or f of x, is equal to a times b to the x. That is the most generic form. There are several other forms, but that is the most generic form. If a is provided, and this is a single x, like x, there's nothing here because the other form would be like b to the x minus 1, all right? If there is nothing with the x, and it doesn't have a minus 1 here, then a is the y-intercept, okay? And b is the rate of change, or what the function is multiplying by. Multiply by. We'll just say multiply by. Okay? If b is bigger than 1, then it is growing exponentially. And if b is in between 1 and 0, then it is not growing, then it is shrinking and dividing. Technically, you're multiplying by a fraction, but when you multiply by a fraction, you are dividing. Now, I did say that this would be another form over here. If this were the case, the b part would still be true, but this would not be the y-intercept, not the y-intercept. It would be like your first term or the value when x was equal to 1. Okay, so it's kind of weird. All right, don't think we're going to get into that one yet, but I did want to give you a full perspective. So we have a savings account. Starts with $100. Oh, wait a minute. I'm sorry. X is equal to the time. Sorry. And f of x is equal to y, which is equal to the amount after a given time. And that amount could represent money, which most cases it will, or the amount of elements like it is on this problem. All right, let's try a problem. We got a savings account. Started with $100. That is the original amount. Okay, so that original amount is the y-intercept. So this is going to be f of x is equal to a b raised to the x. So we have f of x would equal 800. B is what you are multiplying by. But if it gives it to as a percentage, what you're multiplying by is not 4, but it is really 1 plus 4%, or 1.04. Okay? And then we would raise that to the time, which would be 8 years. All right, that is all we have to do. We type that in our calculator. We get 800, 1.04 raised to the 8th power. And after 8 years, our $800 will have turned into $1,094 and about 86 cents. 1094, 86, $sign. All righty. What about if you have a car? If you buy a car, it depreciates. And when you bought the car, it cost $25,000. It's a big chunk of change, but how much will it be worth after 5 years? So, f of x equals the original price, $25,000. Now, if it's depreciating, we're not going to be adding the percentage. We will have to be subtracting that percentage. So it'd be 1 minus 0.15 as a decimal. All right, make sure you're writing the percentage as a decimal. For those of you that are confused by that, you just divide the number by 100. That's how you got 0.15. Then we plug in the 5 for the years. 5 is the time, percentage, amount of money. Type it in, 25,000, 1 minus 0.15, raised to the 5th power, and oh my goodness, that car's value after 5 years is only $11,092.63. So it has lost almost half, no, more than half of its value. That's terrible. Terrible, terrible. Okay. All right, stepping it up a little bit here. Buckle down. There is initially $2,200 in an account, and it is paying 6.5% each year. How long will it take to reach $14,100? So we have $14,100 is what we would like to have. Y is equal to AB to the X. So 14,1,000 is what we would like to have. We put in 2,200. It is earning an interest rate of 0.65, so we have to do 1 plus 0.065 raised to the x power. All right, there's a few ways to solve this, but the main method is going to involve a newer technique that you may or may not have seen. So here is what I would recommend doing. Okay, I would recommend not graphing this because that would be crazy, but dividing by the 2,200. That would be the first step. Divide by 2,200. 14,100 divide by 2,200, and that is 6.409, and you do not want to round that number. You want to store that number in your calculator. Don't round it. Will equal 1.065 raised to the x. Now, you can't divide by 1.065. You just can't do it. You're not allowed to do that. It won't work out. It's just bad news, okay? So the way you would solve this is actually by either ln'ing or logging both sides of the equation. My recommendation is to ln both sides. That way you don't have to think too much about it. All right, so I would ln the 6.409, and that would equal the ln of 1.065. And when you ln the 1.065, then the x just drops down and it becomes a regular x. So this is the ln of a number times x and the ln of this number, and these are all just going to come up to be decimals. So let's type that in our calculator. The ln of that number, I told you to keep it stored in your calculator, so I'm going to enter it down, is 1.857. Would equal the ln of 1.605, so the ln of 1.065 is 0.06297 times x. All right, and now it's a normal equation, and now you can divide. So we're just going to divide by that 0.06297 and divide by that 0.06297, and that would equal x. And I would like to do that in my calculator, so I'm going to take the 1.85, and then I'm going to divide by that. And you can cursor up and you can do that, or you can store it in your calculator with answers. And we get a time frame of 29.49 years. That is a little bit of waiting. It's quite a bit of waiting, but you went from 2,200 to 14,000 by doing nothing. So it's not that bad. All right, let's try another one. We got an element with a mass of 520 grams decays at 25.1% per minute. Whew. That is a crazy element. To the nearest tenth of a minute, how long will it take until there are 60 grams of the element remaining? So let's see. We have 60 remaining. We started with 520, and instead of doing a plus with the percentage, we need to do a 1 minus 0.251 raised to the x power. We divide by the 520, just like we did before to get rid of that. You cannot distribute it. That's a big mistake, is people think they can distribute it, but with this x as an exponent, you can't distribute it. So 60 divided by 520 is 0.115. You want to keep that in your calculator. 38 would equal 1 minus 0.251 is 0.749 raised to the x. Now what we did before is what we're going to do again. We're going to ln both sides. So the ln of 0.11538 would equal the ln of 0.749 times x. And that x no longer is an exponent. It drops down. Now one thing you could do if you don't want to actually type it in and rewrite like I did last time, what you could do is just take these numbers in your calculator and just divide by the ln of the 0.749, and it would just cancel, and you would divide by the ln of 0.749 there. So it would just cancel. All right, so let's do that instead. We got the ln of this guy, and we're going to divide by the ln of the 0.749. And that makes it a little bit easier than rewriting and rewriting and rewriting. And then we got x. X in this case is 7.47, and that was in minutes, so it would be rounded to the nearest tenth of a minute would be 7.5 minutes. So let's see what would happen if we did plug in 7.5 to check our answer. So we had 520 to begin with, and then it was depreciating at the 25%, so 1 minus 0.251. And if we raise that to the 7.5 power, I should get something pretty close to 60. And we did. But remember, we rounded to 7.5. I bet if I changed this to 7.47, it would show up even better. There we go. A little bit closer to 60. All right. We got some easier ones to finish the day off with. This one says a certain species of fishies in a lake increases its population by 9% each year. After 5 years, the population reaches 3,500. Find the initial amount of fish. So this is not the initial amount, that's the final amount. So that would be 3050 would equal the original amount, which was B, 3050. The equation is y is equal to a, b to the x. So we are looking for the a, but we know it's increasing, so this is going to be a 1 plus 9%, and it took 5 years, so 5 would be the x. All right. Well, how do we solve this problem? Well, this one's actually a lot easier to solve because we can actually add 1 plus the 0.09, and that makes 1.09, and we know the exponent, so I can actually raise 1.09 to the 5th power. So 3050 would equal a, whatever 1.09 to the 5th power is. 1.09 to the 5th power is 1.53, whatever, blah, 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 a lot of numbers. 1.53. 1.538. So now we just divide by that 1.5386, blah, 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 blah. So I'm going to divide the 3050 by that. And I got an A value of 1982.29. All right, and what were we talking about? It was a certain species of fish. Can I have 0.29 of a fish? No. No, you can't. So 1982. Fish. That sounds better. All right. A patient receives a medication. Oh, no. And the amount of medication on the drug in the bloodstream decreases by 18% each and every single hour. After 4 hours, 47 milligrams of the drug remains. Find the initial amount of medication. So 47. All right. Would equal, we're looking for the A. We have 1 minus because it's a depreciation, and then we have 4 hours. We solve. We do the 1 minus 0.18. 1 minus 0.18 is 0.82. 47 would equal A times 0.82 raised to the 4th power. Well, 0.82 to the 4th power is a number, and that number is A times 0.452. And then we divide by 0.452. So A would equal 47 divided by 0.452. 47 divided by 0.452 is 103.95 milligrams, which is pretty gosh darn close to 104 milligrams. And that means that it was probably a 100 milligram pill, and the pharmacist messed up a little bit. Plus or minus. Maybe they gave some powder. You know how they sometimes have powder on the pills? It's gross. All right, that's going to do it for this one. Till next time, stay positive, and I will see y'all later. Bye.